When a complex, multidimensional problem is squeezed through a single, linear chat window, the interaction model begins to vibrate. As the variables increase, the structure reaches a breaking point, dissolving into undirected noise. This instability stems from fragmentation. Because standard AI interactions isolate knowledge in ephemeral logs, agents lose their grip on a shared reality. Without a persistent anchor, the model eventually drifts into hallucination. Simply adding more autonomous agents to this environment does not fix the logic. It merely increases the friction. Each new actor adds a fresh layer of entropy to the system, making coordination increasingly difficult to sustain. Maintaining coherence requires a structural shift, the introduction of a metaphysical architecture. This is a framework that exists outside the chat window to coordinate human intention and machine logic through explicit, rigid rules. Moving toward a closed-loop intelligence factory allows the system to govern the thinking process through a physical architecture, providing a stable foundation where autonomous operations can actually function. The BIT ecosystem acts as this factory, utilizing a tripartite design to physically separate the stages of cognition: interaction, reasoning, and memory. The first pillar is BitHub. This is the active inference and coordination layer, the entry point where raw human tasks and signals are captured. The second pillar is BitCore. This is the cognitive engine that processes the logic and orchestrates the reasoning depth required for the task. The third pillar is BitWiki. This is the immutable memory layer, a structured knowledge graph where completed intelligence is permanently inscribed. To stabilize the system, we introduce a mathematical boundary called the hen. This Bardian entity, visualized here as nested fractal wheels, draws a pristine circle around the incoming chaos to define the system's operational reality. By tracing a single task through these three pillars, we can see how this architecture prevents the drift common in standard AI systems. The process begins the moment a human task enters the BitHub community layer, arcing like a signal across the gap between intention and execution. Instead of sitting as a static post, the system immediately routes this input into a specialized environment called a workspace. The workspace is a composable interface. It instantly binds specific tools and data permissions to the topic, forming a rigid structure around the Spark. This transforms the raw inquiry into an active work cell. It is no longer just a request. It is a tool-augmented environment ready for agentic processing. By bounding the input at the moment of ingestion, the system ensures the task remains focused, preventing it from degrading into unstructured conversation. Before the AI executes any logic within the work cell, the environment is encased in a construct. Standard AI uses personas, surface-level behavioral masks that change the tone of the response, but leave the underlying logic of the model unchanged. A construct is fundamentally different. It is a meta-ontological kernel that defines the absolute boundaries of the agent's reality. It mathematically locks three parameters: the logical rules of inference, the admissible actions the agent can take, and the specific tool affordances available. Operating within this bounded universe forces the AI to generate context-true outputs. The agent doesn't just follow a script, it exists within a reality where only valid logic and verified tools are treated as real. This mechanism effectively prevents hallucination, restricting the AI's generative manifold to ensure every output conforms to the domain's reality. Once the construct defines the reality, BitCore initiates the reasoning process through specialized execution geometries. This creates an agentic construct, an autonomous problem solver that pairs a strict ontological boundary with proactive tool use. The first geometry is the node. Nodes are single-purpose, CLI-style terminals. They execute highly specific local tasks, like API extractions or data conversions, with a narrow, intense focus. The outputs from these nodes are then fed into the higher-order reasoning geometry, the core. A core is a multi-phase reasoning pipeline. It forces the data through staged methodologies, ensuring that every step of the analytical process is structured and logical. This staged approach yields reproducible, auditable results. Instead of an unverified chat loop, you have a sequence of reasoning phases that can be checked and validated at every turn. By dynamically combining these single-focus nodes with multi-stage cores, the entire system can solve complex, multi-dimensional problems with absolute deterministic precision. When the core finishes its run, the raw output is not yet the final product of the factory. The system enters a distillation phase. It extracts the underlying logic, the successful workflows, schemas, and templates from the execution. These extracted objects are stored as artifacts. They are versioned, reusable components that future agents can pull from the registry to solve similar problems. These mechanics are paired with guides, which serve as the human-facing reference layer for the ecosystem's governing logic. Because every successful run generates an artifact, the system's intelligence becomes modular. Successful cognition is captured and made reusable, so the system never has to reinvent its own methods. The final, verified knowledge is then routed to its permanent destination, BitWiki. BitWiki is a semantic MediaWiki knowledge graph. It functions as the machine-readable long-term memory for the entire ecosystem. Both human operators and AI agents query this identical, unified graph. This ensures that every actor in the system is anchored to the same canonical source of truth. This creates a feedback loop. When new knowledge is inscribed into the wiki, it instantly updates the context available to the workspaces and the cognitive engine. This is the autonomous knowledge lifecycle. Ingest and capture, distill the mechanics, execute the logic, and publish for reuse. By replacing ephemeral chats with this recursive factory, every task strengthens the underlying knowledge base. The system compounds its own intelligence, ensuring that as the network grows, its shared reality remains stable and precise.